Hey, my friend, welcome to again. We will continue as at this point. At that point, we will speak about or we will discuss about audio dropped inaudible sounds, how we can reduce the ineffective points. Let's do together. Let's come here, be clear and be fast. The human, not human, human, ear has ear has limitations. That's true. To what it can hear, to what to what can hear. What is this? What is this? My spelling issues too much. What it can hear, to what it can hear. Audio compression algorithms. Audio compression algorithms. Algorithms can analyze an audio. Can analyze an audio. Can analyze and not end an audio file and discard the sounds that are the sounds that are outside our hearing, outside our hearing. This is the important point. Notice it. Our hearing, because we are focusing to discarding place, which is we want to reduce this place because human ears can notice some kind of file, no sounds. I mean the frequency. I mean, okay, if the frequency come up, even if the frequency come up, then you can't notice it. I mean, did you get what I said? Capacity. Okay. A process known process known as perceptual audio coding. Audio coding. One interesting limitation. One interesting limitation. An interesting limitation of our ears. Of our ears is known as temporal masking. Masking. This is the critical point. Just notice it. You're really careful about this place because our ears is this cognitive information. It's just masking some temporal. So sounds like some sounds is coming very up, and your ears just knowing what will happen there. Just some with some knowledge. It's just implementing there's some temporal masking. Okay, temporal mask. I mean, that's when a sudden sound. That's when a sudden when a sudden sud- sound can mask, hide other sounds of period after it period after it occurs down occurs and and even a bit before before. So what we are saying here, one interesting limitation of our ears is known as temporal masking. We discussed it. That's when a sudden sound can mask, hide other sounds of a period after it occurs and even a bit before. I mean, yes. For example, imagine a song with a loud drum. Imagine a song with a loud with a loud drum beat. Mm, The beat mask the beat masks the beat masks sounds for sounds for about sounds for about 20 milliseconds mhm, before it happens happens and for up to for up to 200 milliseconds after it happens. Yep, this graph illustrates this um, this graph illustrates illustrates the masking effect. The masking effect. Yep. Let's look together what I'm speaking about or what I'm saying right now. Okay, let's look the image here. Mm, yeah, where is our images? Which one is that? Which one is that? Yep, here. Zoom. I think it will be again big. Oh, crazy big images again here. Let's tag it to small place and put it to here. Yes. Let's go there and come down. Yes. Uh, in this point, you can understand before maybe I can do something. Let's do together. Yep. It is wrong or right. I think this is not bad, okay? So in that point, this pre-masking is it start to implementing. In that point, you can think like 20 milliseconds. This point, after that, it's we have here 200 millisecond. It's coming down and it's going. So what we said about it, we said, for example, imagine a song with a loud drum beat. The beat masks sounds for about 20 milliseconds before it happens. So it's mean here 20 milliseconds seconds before it happens, and for up to 200 milliseconds after it happens. So in that point, when its drums come up, some sounds increase, uh, then it's masking to it. uh, it's all just you think the algorithm is just delighting this place because our ears not noticing at that point we have some bounding. uh, so I mean we have some limitation to heard some sound with the details. That's you can understand like that. Let's come to down to this point right here and say why it is bigger now. I don't understand what it is doing there. Go to up. Okay, we can come here at that point. Yeah, it is good now. Let's say the computer sees those hidden sounds. The computer sees sees those hidden sounds, those hidden sounds in the recorded in the sounds in the recorded hidden sounds hidden sounds those hidden sounds in the recorded audio file, but our ears but our ears can't hear them. A computer can understand it with the algorithm, but humans ear cannot understand that. So audio compression algorithms. So audio compression algorithms can safely discard can can safely yep discard card can safely discard that information or represent in represent it with favor bits, which is other way. Let's come down. Compression algorithms not algorithms. Oh, why I'm doing wrong too much spelling wrong. Algorithms can also use other limitations limitations, yes, of our natural natural auditory auditory process, like high frequency. Uh, so just I'm proposing you at that point you need to be careful about this kind of algorithms. You need to understand details of in depth. It will be amazing for you. It's just my recommendation for you. High frequency limit, like high frequency, see, high frequency limit and simultaneous simultaneous masking. Mhm. So if you if you if you'd like to learn more, but again, at like to learn, if you'd like to learn more, you can research them. You can research to fascinating field of fascinating field of mm, acoustic Psych, psycho, acoustic, and it's going like that. Psycho acoustic, like that. Acoustic, sorry. Let's take it down. I don't know what I did there. Acoustics, right. You can search this, but okay. What is it? In some way. Okay, now let's speak about compression quality. Come down. Let's say compression quality. Quality, right. Okay, let's tag it again in blue, which is my favorite color for subtopics. Okay, I propose you also when you need something like that, you can propose it like that. When we use a lossless compression algorithms, when we use a lossless compression algorithms, compression algorithms, we can always we can always reconstruct 100% of the original data with lossy compression algorithms algorithms we are we are losing some percentage of the original data, right? Of the original data. So maybe 5%, maybe 10, maybe 70. Yeah. So let's say, how much do we lose? Do we lose? What do you think? We can, this is the happy news for you. We can decide it. This is all about your uh, bandwidth of your internet. uh, the situation can change. I mean, the status of your process. We can really that decide that based on our use case for data. Yep, come down. And let's say, consider earlier photo of the earlier photo of the cat in the hat. If the plan is to put if the plan is to put the plan is to put uh, that photo in a that photo in a presentation about cat, suggesting we want to do some empresstic uh, experimental things. Okay. Cat fashion. Yep, fashion. And and project it project it on a large screen on a large screen. And we need details. we probably want to keep we we probably want to keep as much detail as much detail as possible. In that case, we can either in that case we can either use a lossless compression, lossless compression algorithm algorithm like algorithm like JPEG JPEG, like PNG, sorry, not JPEG. We can use a lossless compression algorithm like PNG, not JPEG, this PNG. Says for about lossless compression algorithm. Or we can use lossy compression algorithm like JPEG. Okay, the situation can change for your status. Just think, if you are if you want to give this images onto screen, with the big screen, you need to use lossless compression algorithms, so which is helping you to do make pixels clear and precise. I mean, but also uh, don't gonna extremely make things in the hard way. Just try to understand, if you are sending your images or your kind of things in internet, or if you're loading something there, just you can use lossy compression algorithms to to make things very fast than lossless compression algorithms, because uh, it will take amount of space from your store, I mean. Okay, so I'm speaking about lossless, so lossy will be good way for about some kind of this stuff. So JPEG is representing lossy compression most of the time. PNG is just working for the lossless compression algorithms too many times. So it is specific, okay, and it's sophisticated, and so you can check if you want too much information, and specify specify a high quality. Just you can decide it, if you want to 100%, if you want to 80%. For your bandwidth, it's also important there, okay. If your bandwidth is little, I mean your internet is not speed, so not too much speed, fast, your internet speed not too much fast, even so, then you need to use the lossy compression algorithms. You need to understand these steps, okay. Algorithms, right here. Algorithms, okay. High quality, like 100%. So further editing applications, in applications often give you those options. Yeah, it's always asking you which quality you want to load your images or your videos or some stuff uh, into the internet. So it's just specific, okay. You can indicate it, you can deny that, I mean. Okay, okay, let's put here what I want to show with you about specify. Let's look here again, other images. Let's do together. Where is that quality 8? Yes, so uh, I mean that one, right? Okay, look at this as JPEG. It's asking you to do quality. You can play with the settings here about your quality. You can reduce it, you can increase it, you can really indicate what you need in this point, at that point. Even if you want to load your files into internet, you need to reduce your quality. If you're increasing, then you need to wait for some situation. Just think you have a friend in the in some country, and internet speed or bandwidth speed is not too much good, then so you need to send them the not high quality and quality, I mean. Okay, let's come down, and let's say at that point Which is just put here. Come down. And let's say at 100 quality. At 100 quality. The 300 by 400 photo, this is the pixel, photo takes up 169 kilobyte of space. So this is 300 by 400 pixels, which is you increasing with the 100 percent quality. If you decrease your pixel size, then your quality will reduce. Also, just you can take average of the things. Okay, let's take cat 9. Where is the cat 9? I need to write this one. This is the cat 9. Yep, this is with the 100% quality. Look, the details is looking good. Even if we try, well, maybe we can look the details. Have lots of pixel there, and it's looking amazing. Now we will do some process together. Let's do it. Maybe we can make it little small because it's taking lots of space on our screen, like lossless compression algorithms. Let's come down. Okay, then to here. Let's say, what if we want to use that? What if we want to use that photo in a website, and our target users for the website users for the website are in another country a country on love and with I told you, even if even I gave you that details, bandwidth connections. Okay, the smaller the file, the smaller the file, the faster the download. Yes, we want them to see the we want them to see the photo but for this use case for this use case for this for not for sorry bit but for this use case But for this use case, high quality isn't as important. High quality, high quality, quality isn't isn't. What is this? This issue is too much. Isn't as important. Isn't as important as download, downloaded, downloaded speed. Download speed. Sorry, not downloaded. Okay. Will definitely, definitely. Um, want to use a lossy compression algorithm. Want to use a lossy compression algorithm. See, compression. Lossy compression algorithm. Algorithm, and we can specify a lower quality, and we can specify lower can specify a lower quality when exporting. Yes, the algorithm can tweak. The algorithm can tweak its internet deals. Its internet dials to simplify details. To simplify details even more. Okay, so this is again our other image. This is quality 10. Where is it? Stack quality 10, quality 10, this one. Okay, which is again JPEG, and this is now 60%. This is faster than others, and at that point, let's tag again this pencil to here. Okay, let's close this also. Yep. And let's say at 60% quality, the photo tags up. Photo tags up 48 kilobytes. Have you seen we reduced? Now you will see our image. Really, just check it. What will be now? With 100% quality of about cat image, now we will look for about 60% quality. Yes, this is here. What do you think? Did you notice? Did you careful? What is different between them? Yeah, because we separated brightness, we separated chromas, and we just worked on chromas a little bit. We took average of the colors which is closest to each other. We just took average of them. Then we did this is we just decrease it from from 169 kilobyte to uh, 48 kilobyte. It is amazing. Okay, then you don't know what it's changed now to here. So this is amazing for me like that, but I don't know what do you think. At that point, this is good news. At 60, let's come to here and put there is, and let's come down. Okay, that still that still looks pretty good, pretty good. Definitely, definitely usable for a love, usable for a for a love and with website. Yep. How low can we go? How low can we go? Here's the photo at 1%. What do you think? What will be, what person quality, what it will make our images, our cat? Let's look together. From 100%, from 169 kilobyte to we increase it. So we decrease it to what? 60% quality with 69 I mean 69 kilobyte. We also decreased pixels, I mean average of pixels, I mean the color with the chromas. Now we will look one. What is one? This is the one. Yep. Yup. This is 60. This is 1. What is different between them from this point? But if you go details, now you will see a lot of things in that point. Have you seen the eyes is coming here, eyes effect coming onto cat? Yep, it is. So let's come down. Let's close it and come to here. Maybe not here, maybe just, yep, here. So let's start to write it. It's definitely not perfect. It's definitely not perfect. The green of the eyes, the green of the eyes, green of the eyes seems to be smearing into the fur, to the fur. Yep. And there are artifacts, and there are artifacts. So where the hat meets, where the hat meets the chair, where the hat meets the chair, it's the chair, meets the chair. So what I'm speaking here, it's here. Okay, just let's go detail in that point. Let's go up little to that point. Yep, here. Yes, and then come little dot right. Yep, I'm speaking about that point. a little bit too. Maybe we can use this tool here. Yep, I'm speaking about that point. Let's look. This some kind of green from us is screaming to here. Let's look into the detail. Let's go inside it. Yep, it is here. Have you see? So this is the details of place. It's just screaming with the one quality. Okay, because we are going to tagging average of the pixels. It is little bad. If you go into details, it will be crazy. Chair, let's say chair, but it's also only, but it's, but it's only, but it's only 12 kilobyte. It is amazing, really, because from 169 kilobyte to what we did come to just 48 kilobyte. Now we reduced it to just 12 kilobyte. You can send everywhere. You can send someone very fast with a very fast speed. You don't need to think about bandwidth too much, really. So, I mean, for the low bandwidth, I mean, let's tell it here. Let's then mm, a tenth of the original size. Tenth of the original size. Of the original size. It's impressive. It's impressive. 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 Effective. How much information we can lose? How much information? Information. Information we can lose. Yep. But still convey so much detail. But still convey so much so much detail. We can also specify quality. We can specify quality for lossy compression algorithms. Algorithms that transform audio and video files, from audio and video files. We video files. Yep. You've probably seen low quality. You've probably seen low quality, highly compressed, seen low quality, highly highly compressed video